Exercise 1, whole numbers. Much of this class, especially the beginning few weeks here, is going to focus on vocabulary. It's terms that you have heard in the past, but you may or may not recall. A big part of the ACT, and there's many questions where if you don't understand the way the question is being asked or what certain terms in the question mean, then you're not going to be able to solve the problem, even though mathematically you may be able to do what they're asking you to do. You just don't understand what they're asking you to do because you're not understanding the vocabulary that goes along with it. The real number system. A real number is any number that does not contain the imaginary unit I. For most of you, less if depending on where you're at in Algebra 2 right now, you probably have not even dealt with the imaginary unit I. So for the most part, a real number is any number that you have any concept of at this time. Rational numbers is any number that can be written as a fraction. So any fraction is automatically a rational number. Any integer or whole number is automatically a rational number because remember, any whole number can be written over 1 to make it into a fraction. Also, any repeating or terminating decimal, repeating meaning that digits repeat over and over again. That's when we use the repeating bar to indicate that it's a repeating decimal, or terminating decimal meaning that it's a decimal that ends. Integers, positive and negative whole numbers. So the set of integers looks like this. So we're not talking about any fractional values. We're not talking about any decimal values. We're simply talking about all the positive and negative whole numbers. A subgroup of the integers then are the whole numbers, which include 0 and all of the positive integers. So we take everything that is already an integer and we take out all the negative values. There's what the set of whole numbers would look like. An irrational number are decimals that do not end or repeat, or any radicals that do not simplify to an integer value. The second part there, any radical that does not simplify to an integer, basically means that anytime you have simplified any radical, if there's still a radical left in your solution, then it has to be an irrational number. In other words, if you had the square root of 9, the square root of 9 we know is just equal to 3. Therefore, the square root of 9 is a rational number. The square root of 10 does not break down to a nice integer value, so we know that that is an irrational number. So anytime we have a radical that does not break down to a nice integer value, we know that that radical has to be an irrational number. Most famous irrational number that you use all the time in geometry relating to circles is the number pi, which is 3.14159, and so on. It keeps on going forever, never terminates, never repeats, therefore it is an irrational number. The 4 basic operations of addition, subtraction, multiplication, and division. If I tell you to add, subtract, multiply, or divide, you're going to know what to do. There are other terms that apply to those same 4 operations that you may or may not know, but it's important that you get to know if you don't. Sum is another way that I can ask you to do an addition problem. Find the sum of 5 and 7. Difference. Find the difference between 10 and 6. Product means multiplication. Finally, quotient means division. A lot of time in ACT problems, you will see sum, difference, product, and quotient rather than addition, subtraction, multiplication, and division. They mean the same thing. It's just another way of writing it. A remainder. Remainder is what is left over in a division problem. So if I take a simple division problem here, 3, and I divide that into 10, 3 goes into 10 3 times. We multiply, subtract, 1 represents our remainder. And remember, a remainder is a part of what we're dividing by. So this 1 means that there is a 1/3 left over in that division problem. Order of operations is probably the single most important thing that you have a very good grasp on. A lot of students know how to do some things in Algebra 2 and even pre-calculus, but they get the problem incorrect because they simply do not follow the order of operations. The acronym that we have to help us remember order of operations is Please Excuse My Dear Aunt Sally, which is a very good acronym to help us remember, but sometimes can be a little bit misleading because there are it appears that there are 6 parts then here to the order of operation. There are really only 4 steps in the order of operations. First one, the P represents parentheses. Always simplify anything inside parentheses or brackets or any kind of grouping symbols first. Once parentheses have been taken care of, the E represents exponents. Simplify any exponents that appear in the expression. The third step in the order of operations, and this is where some students make errors, is to multiply or divide. We will not necessarily always multiply before we divide. We look at all the multiplication and division together, and we do it in order from left to right. Fourth and final step is to add or subtract. Again, it does not necessarily mean that we're going to add before we subtract. We're going to look at all the addition and subtraction together, and we're going to do it in order from left to right once again. Some more vocabulary. Factors are numbers that divide evenly into other numbers. An example of this, factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Those are all factors of 24 because they all divide evenly into 24, leaving no remainder. Multiples. If a number is divisible by another number, it is considered a multiple of the number. Examples, 24 is a multiple of each one of those because I can multiply each one of those numbers to equal 24. A prime number. Prime number is a number that has exactly 2 factors, one in itself. Exactly 2 factors. So the most common mistake here is students think that 1 is a prime number. 1 is not a prime number because it only has 1 factor. That 1 factor is 1. Has to have 2 factors, 1 and the number itself. There's an example of the first 10 prime numbers. Each one of those numbers in that list has exactly 2 factors, 1 and the number itself. Odd and even numbers. Usually there's about 1 question on every ACT that deals with kind of theoretical, what do you know about numbers? A lot of times it will either be about even and odd numbers, or what we're going to look at on the next slide with consecutive integers. An odd number is a number that is not divisible by 2. In other words, there is going to be a remainder. Okay? An even number is divisible by 2. That's the difference between the two. Okay, so even numbers end in 0, 2, 4, 6, or 8. Odd numbers end in 1, 3, 5, 7, or 9. Some principles of odd and even numbers. And again, this is going to get into the theoretical aspect of just what do you know in general about numbers. An even number added to an even number or an even number subtracted from an even number is going to give us an even number. An even number added to an odd number or an even number subtracted and subtract an odd number gives us an odd solution. An odd plus an even or an odd minus an even gives us an odd solution. And the fourth property of addition and subtraction are 2 odd numbers added or subtracted is an even product. So notice, again, you're not going to want to have to remember all of these rules. Try to come up with some way that you can remember them by generalizing. In this case, you can generalize and say, well, anytime that we have both odd or both evens, that's when we get an even solution. Anytime that we have one of each, an even and an odd, that is when we get an odd solution. With multiplication, 2 even numbers multiplied together is an even number. An even number times an odd number is an even number. An odd number times an even number is an even number. And finally, an odd number times an odd number is an odd number. So with multiplication, we can see that there's only one time that we get an odd product. That is if we have 2 odd numbers that are multiplying. Anytime an even number is involved anywhere in our multiplication, we're guaranteed that that product is going to be even. Last one, consecutive integers. 2 vocabulary words you need to know. Integers we already talked about. Integers we know are positive and negative whole numbers. Consecutive means they come one right after another. Consecutive integers immediately follow one another. 1, 2, 3, 4, 5, 6, 7, and so on. All of those are consecutive integers because they come one right after another. In general terms, 4 consecutive integers: first integer, second integer, third integer, and fourth integer. If we call the first integer n, I know to get to the next integer right after that, we add 1. That's how we get n plus 1. Add 1 to that, we get n plus 2. Add 1 to that, we get n plus 3. Add 1 to that, the next one's going to be n plus 4, n plus 5, and so on. If we just pick a random integer, start at 3, consecutive integers after 3, add 1 is 4, add 1 is 5, 6, 7, 8, and so on there. Those are examples of consecutive integers. Consecutive even or odd integers. A little bit different now. Consecutive integers, to get to the next integer, we just add 1. If we start with an even number and I want to know the next even number after that, we can't add 1 because that would be an odd number. We need to now add 2. Likewise, if I want consecutive odd integers, start with an odd integer. Let's say 5. What do we add to 5 to get to the next odd integer, which is 7? We add 2 to that as well. So in general terms, first integer, second integer, third integer, fourth integer. Doesn't matter whether I pick an even or an odd. We have to add 2 to each one to get to the next even or odd integer. So if I start with n, next one is n plus 2, n plus 4, n plus 6, n plus 8, and so on. If it happens to be an odd integer, it goes 3 to 5 to 7 to 9 to 11, and so on. If I start with an even integer, 4 to 6 to 8 to 10 to 12.